So it's lesson 41. We're still marking on the Pythagoras class butterfly. When you get the sum, the most important thing in a math paper is to identify what is this teacher asking me. Where does this fit into the bigger scheme? Is this geometry? Is this algebra? Is this, what is this? So if you get to this, I hope you'll know that it is, but it's true. Okay? And it can't be in paper 1 because it's not in paper 1. And then when you start reading the sum to know that you've now done the tree graphs. This is not asking you to sketch a tree graph. And then the first question usually is something about Pythagoras and cast with a little butterfly. We are going to use one of those sketches. So in this one, there was a little bit of a twinge to it, because you cannot see if cos is positive or negative, and you can't see what the two values are because of that 2 over there. First thing you have to do is write it as cos theta equal to?
Negative 1 over 2.
Negative 1 over 2. That's where you could have started. They could have even said plus 1 equals 0. And you have to do the same procedure to get it to. Knowing what cos is. Cos is the ratio of two sides. Could it just be 2? Then it would be 2 over 1. Are you with me? So there's two sides, and I'm going to look at the cos ratio, and I know the cos ratio is positive and negative. I'm looking for a negative cos ratio. Now you've got to start getting that cos diagram into your brain. Knowing that cos is negative in the second and third quadrants. But that's not enough, so I have to give you some more information. The last information was that tan is positive. Now where is cos negative as well as tan positive?
Third quadrant.
That's only the third quadrant. So therefore you get a mark. Where's your angle? Remember I showed you the little dot, so here's your angle and it's called theta, or whatever name I give you there. It's actually, and today we're going to start working with the reduction formulas. It's actually from the standard position in positive x-axis all the way around. That's where your theta is, but you reduce it into a acute angle, which I'm going to teach you today. So that's where your little acute angle will then be. Now, where do the 1 and 2 go? Cos is adjacent over hypotenuse. You here. So this is adjacent and this is hypotenuse, and then you're going to look at the signs. This is the radius.
It's
always positive. So the minus has to go there with the negative 1. Right, and I'm searching for y. Unfortunately, it's not the golden triangle, so you'll have to do the sum. But I don't want to see 17 steps. I want you to get there as quick as possible. So it'll be for y square, you'll say r square minus x square. And even that's too much. You can just dive right in and say it's 2 square, which is 4, minus the 1. But I do want to show you something, because some of you are going to make this mistake. Is this a plus?
Yes.
Nope.
No.
Mistake. Because order of operation says you first do powers and then you multiply. You don't multiply and then square. So this answer will be negative 1. So that means 4 minus 1 gives me, and please take your calculator. Your calculator will tell you if you say 2 to the power 2 minus, and you have to use the brackets, negative 1 squared, it will give you 3. What is 3? Nothing is 3. Y square is 3. So that means that y is either plus or minus root 3. So is it positive or is it negative?
Negative.
Look at where you're working. So that's the applicable one. This is not applicable. Now, if you had forgotten about that, you would have written root 3. That would have been a mistake, and then we carry on. Because the question will not just end there. My actual question was, if I give you all this information, where you go get your little butterfly, get your Pythagoras, then you still have to answer my question, whether there's 1, 2, 3, or 7 questions. The question was, find
Tan
theta minus 2. So you have to go work with the sketch. On your sketch, what is tan? Tan is opposite over adjacent. Now I know that this is negative 3. So it's negative root 3 over
negative 1.
And then the minus 2 or the plus something or the root something or the square something, you just put it in there. But the reading from the graph is 10. And then just put it into your calculators, please, and give me an answer.
-2 minus root 3.
Plus, isn't it?
There's a minus.
Because it's a negative over a
Positive.
negative, which gives me a positive. And your calculator gave you the one with the root at the back. Could you not have written the root 3 in the front? No problem, but if you put it into your calculator, it always does what it does with the quadratic formula. And the quadratic formula being punched in there, programmed in there, will always have the root at the back because it comes from the quadratic formula. So there's no problem when you swap them around. Finish. How many marks? 5 or 6. Correct quadrant, doing the Pythagoras correctly, reading off from the graph answer. This could have been a 4-mark sum, but maybe a little bit more over there. Okay, then the alternative. Now, if I do give you a trigonometric question paper at this stage, and I say just trig for 50 marks, then I have the option to ask you both these types, because they're actually 2 types. You've got to get the correct quadrant, and you've got to go get your Pythagoras, you've got to read off. But this is a very specific one that they love asking, so I love asking it as well. If I ask you to say something is equal to K, or P or T or any alphabet letter, and write it in terms of K, remember that's just my abbreviation, write in terms of K, you must know, aha. Madam said in terms of K, in this situation, has to be that Pythagoras cast butterfly sum. Now, if I have to go choose a quadrant, do I have enough information?
No.
Yes. I don't have to give you 2 pieces of information to say cos is negative, tan is positive. It says 33 degrees. So that is obviously the
First quadrant.
first quadrant. And now after today, you'll know that whether I give you 150 or 260, you're going to reduce it back and you're still going to get back to the first quadrant. Are you with me? Well, there's a little bit of twinge to it. Let me just correct myself there, but basically that's what's going to happen. Then for tan being 33, this is the angle there. Its name is now 33. So you're going to get K over 1. So K is the opposite over adjacent, so it's K and 1. Then you've got to go work out the third side using Pythagoras, and for that you'll get
Root 1 plus K squared.
Can I write K squared plus 1?
Yes.
Just because she said 1 plus K squared, it doesn't matter. K squared plus 1. It's actually 1 square plus K square, and then you put it in the root. But then we know that 1 square is 1. But if you still want to write 1 square, so what? It's fine. But you're going to get Pythagoras. If you write it there, it's fine, but we like to see Pythagoras. So maybe write R is, with the reason nice and clear, done. But if you write it there and you write Pythagoras next to it, it's acceptable. Something's got to be done with that. The thing I want you to know from these Pythagoras cast diagrams, I'll never just say, okay, that's it. I'm going to ask you to go read off of the graph something else. And the question was, go find me cos square 33, and that was it. Plus something, minus something, divide something, root something, whatever, it doesn't matter. You've got to go read off cos 33 and know that that cos 33 has got to be squared, and it's still got to be times with 2. Okay, read off of the graph. So cos 33 then is, if I'm standing here, cos is adjacent over hypotenuse, which means it's 1 over
1. The
the whole root thingy. Guys, we've talked about it. Let's talk last time about it again. Why is that not just K plus 1 coming out of the roots?
Because there's a plus.
Okay, so there's no rule for plus because it's still actually exponent rules. Roots are actually exponents, right? And in roots, you don't have, or in exponents, you don't have rules for plus and minus. That's factorizing stuff. You can only take it out if it was multiplication. That's the answer. Okay, is that the answer?
No.
You've got to square it. So it's got to, you have to simplify, right? So it's going to be 1 over, and then just K squared plus 1. Do you agree? Yes. Because the square and the square root are going to cancel each other out, and 1 square still stays 1. Oh, but there's still a 2 there in the front. So can't I put it there at the top? Also leave it in the front. I don't like that. We'd like to simplify. Okay, even if there was a root at the bottom in the final answer, are you going to do something about it? Because the root has got a variable in it, it's not to say that it's going to be an irrational number. That's it. End of the first piece, Pythagoras, cast, and the butterfly. Right. Okay, so we've spoken a little bit about it. You are going to study and learn quite a few things. I'm going to say it again. You're at the tip of the iceberg that goes way big here at the bottom. So we're going to start chipping away. So there will be some things that bother you for a while or so until we get to everything, okay? Mainly, we're going to be starting off with such easy, I'm never going to ask you this question in a question paper. This will be part of a much bigger sum that's going to count 5, 6 marks. But in every situation, whenever you come in a tricks sum, when you see something like sin 310, this is the golden rule. You must reduce or change if you want every angle back to an acute angle. Not acute angle or acute angle, right? Guys, it's a joke. Which means quadrant 1. Now, I just want to put you in some perspective here. If you do go and do a sum, okay, let's do the first one first. I'm going to teach you that there's some magic here. I call it the poof sums. You're going to see now why. I do this so that sometimes those tricky, freaky, silly things may help you remember. So if you get something like 310, I'm taking you back to our cast diagram and saying 310 would be here, agree? Because you know this is 0 to 90, 90 to 180, physically degree measurements. So 310 should be somewhere about here. Do you agree? Now man is saying take them back to the first quadrant. Now the technique for that is there are 3 formulas. Let's stick to the math for the moment. 3 reduction formulas that you are always going to use, which are, for quadrant number 2, you are going to say 180 minus. For quadrant 2, what do you think you're going to say? Plus. 180 plus. And for quadrant 4, you're going to say 360 minus. So immediately you must start thinking, why can't I say 90 plus? We're getting there. These are the 3 that's your be all and end all that you are always, if you have a choice, going to use. You're going to say 180 plus minus 180 plus. So if in a sum here pops up 180 plus, you must know that's third quadrant. If somewhere there's a 360 minus, you must know that's fourth quadrant. Okay guys, so at the tip of the iceberg, I'm teaching you how to get into this. So if you see 180 minus, you know second quadrant from today. For now, I'm just teaching you how to go swap it around. So if I say 310, do you know that we're in the fourth quadrant? 310 is bigger than 270, are you all with me? So I'm teaching you that you're going to use 360
minus.
Okay, now that is the magic behind it. You cannot say it's 300 plus 10 or 320 minus 10. There's no magic going on there. It's got to be one of these 3 reduction formulas. 180 minus, 180 plus, 360 minus. You're going to hear me saying that a million times. Now 360 minus what? Minus 310. No. That's not the same. It must be minus 50. Which is going to bring me back to a acute angle. 310 is exactly equal to 360 minus 50. That's still 310, right? Now here comes the magic. Listen to this. Here comes the magic. Because that only 180 minus 180 plus 360 makes the magic happen. So the 360 minus just goes, poof, gone. So what's left? And that's not right, man. It's not right. Because there's something else that you've got to go do. The magic happens that if you have 180 minus 180 plus 360, the rest of it goes poof, gone. So it's just 50 that's left. 360, including its minus, is poof, gone. But it was the sin ratio. And you were in the fourth quadrant. And the sin ratio in the fourth quadrant is
Cos.
negative.
Oh, sorry.
So follow the rule. You do go poof, and it's just sin 50. But you used to actually be in the fourth quadrant, and in the fourth quadrant, sin is negative. So that's why you write negative. Now, the only way to convince you about this is take your calculator. Put into your calculator sin 310. What do you get? Negative? 0, let's put round up to 1 decimal for now. 0,8. Please put into your calculator, but you've got to put into your calculator negative sin 50. What do you get? It's the same thing. I try to convince you that answer on the calculator and that answer on the calculator are the same, so that should be convincing you that the technique is right. Now, to show you how it works, some perspective here, is if you go and look at 50 degrees, and you do look at the sin graph, not cos and tan, but the sin graph, sin 50, then that means that sin 50 should have then been 0,8, like you said. Okay? But why is it negative? Because you were busy with sin 310. Meaning, and all the time you're going to be doing what I'm teaching you there, not on graphs. This is just for some perspective. So there you're going to go 360 minus, how much? 50, right. So where am I? At 310, which is actually what I'm looking for. But it makes that 50 degrees there with 360 minus. And what's that answer going to be? Oh, my sketch is so skewed. Still going to be 0,8. What's this answer going to be? Where's that, do you think?
320.
320. Because this is 50 degrees, this is 50 degrees, so that should be 320, right? And this should be 180 minus 50, which will give you. So all of those answers will be the same. Because there's a pattern going on here. All of them, but what about the negativity of it? So this one over here should then be 180 plus the 50, right? It's going to give me 50, right? And then this one should be, if you subtract there another 50, it's going to be 2. Oh, where am I now? I have written this wrong. 90, 180. Oh, guys. You were going to say, why didn't you? Okay, I'm sorry. So this will then be 230. This is mine. 270, right? Just let me finish this. So it's 50 added there is 230. This was 360. Sorry, I was counting wrong there. So this is 90, 180, 270, right? 360. So there should be now what we said was 320, no? 10, right? 310 because it's 50, 50, 50 all the time. Now it's going to work out fine because my answer is positive there. So this answer here will be negative 0,8. Oh, the sketch is horrible. So when you go all the way down here, it's all the time going to be negative 0,8. This, only this, 180 minus 180 plus 360 will let this happen for you in all of the graphs. I'm not going to do that all the time because we're wasting time. But the first thing that you're going to be doing is you're going to find out which quadrant it is so that you've got the correct magic words going on here. Then after doing poof, you can't just say it's sin 50 because it's not. That was in the fourth quadrant where sin is negative. So there's two things you do. You find out the 180 minus 180 plus 360 minus, and then you decide on the sign. And that's it. Now this question, like I said, won't even be in a question paper, but if I asked you, I would have said, work this out without a calculator. No, couldn't be without a calculator. I would have said, take it to an acute angle. So you'd stop there. But just to convince you, if you put that in your calculator and that in your calculator, both gives you negative 0,8. Alright, let's try another one. Now we're at cos, so it's not going to work there. So we first of all got to decide what's going to be the magic numbers over there. So there's 290.
right? Isn't the
It's still in the fourth. You gotta be careful that you don't say it's third and fourth. Say you thought it was the second, so it's 180 plus. It's 180 plus. Oopsie. What's wrong? It's still obtuse. It's not an acute angle. So you'll find out your mistake quite easily and quickly. Are you with me? The reduction must be to an acute angle. So it's not 180 plus. Think again. This is 270. It'll be again 360 minus. But not 360 minus 290. This must give me 290. So there must be a. Are you with me, everybody?
yes, ma'am.
Then it goes. Thank you. But is that answer correct now?
No.
You got to check for the sign. You're busy with cos in the fourth quadrant.
Yeah.
Was right. Because cos in the fourth quadrant is positive. You have to write a positive there. Maybe for now it won't be a bad idea so that you know that you checked it. But it is going to be positive. How will you convince yourself? Because we don't have time for all this. Calculate cos 290, calculate cos 70. Please give me an answer so I can write it here.
0.3.
Thank you.
0.3. No, 4.
3.
Okay. Let's go for the next one. Guys, are we getting in there? Are you doing these poof sums?
Yes.
Tan 140. Where am I? In the? Sometimes for certain kids, this is the worst part of the question. I don't know where I am. 140 is in the second quadrant. Magic word. Not poof. 180 minus. Second quadrant 180 minus. Third quadrant 180 plus. Fourth quadrant 360 minus. Right. So 180 plus minus.
14.
And if this isn't acute, then you've got the wrong magic words. Then we go. Okay, including, right, guys, including the negative. 180 minus is the poof. 180 plus is the poof. 360 minus is the poof. But is this now correct? Because you got to check. You were in the second quadrant. And tan in the second quadrant is? Negative. So to do this reduction back, you still got to get the correct value. Although it's now acute, you still got to get the correct value, and the value has something to do with the sign as well. If you check that, please give me an answer.
Negative 8. I mean 0.8.
Okay, and it has to be negative. Think about it, because tan in the second quadrant has to be negative. Last one, quickly. So, second quadrant, so we write
180 minus
70, right? And we go poof, including the 180 and the minus poof gone. And it is positive, because sin in the second quadrant is positive. Answer, please. 0.9. Guys, now this, remember now, I'm teaching you to reduce. We're getting into much bigger sums from here on out. Okay. Okay, so the golden rule all the time at matric. If you're busy with tricks and cos tan, you should look for what? Acute angles. But now where is 600 degrees?
Nowhere in the quadrant.
This thing has been going, right? Measuring all the way to 360, and again will give me 700, and again will give me 1,000 something. So I can ask you for 6,000 for that matter, but if you know the principle, you'll be able to adjust. The thing about this is, just like I showed you, you've got the sin graph, it goes on and on and on and on and on. Thousands of degrees, millions of degrees. How do I get back to the acute angles? You're going to want to do that, which I've just showed you in the first 4 quadrants, but first get there. How will I get from this answer over here back to there? Just subtract from there to there?
90.
There to there?
180.
360. Because the period is 360. Every 360 it starts recurring. So from there to there is 360, 360, 360, and then another 360. Okay, I am where I should be. In the first quadrant, because it doesn't have to already be in the first quadrant. I'm going to show you now. So the golden rule is just minus 360 as much as possible. Very, very mathematical. Very mathematical. No. So you just take away as many 360s as you possibly can, and you don't even have to show me that. So you go 600 minus 360, give me an answer quickly. 240. And now what? And now it's one of those sums. Will you complete it for me? And over here? 908 minus 360? It's still 500 and something. It's too big. Too big, so?
Another one.
Take another one.
188.
How much?
8.
And then what?
188.
Again. And then what? Same procedure. Will you complete those two for me? Guys, we just started.